Hi everybody. I wanted to put together a quick video with coterminal angles because many of you were missing today and you maybe would want to catch up on the things that you weren't there for, and I want to make sure that this is around for a reference. We're going to look at coterminal angles today. Coterminal. Coterminal angles are angles with the same terminal edge, or terminal side. Let me give you an example. Here is a 60-degree angle. It's one that we're pretty familiar with. And there's my rotational amount, 60 degrees. Okay, if I go all the way around and I increase my rotation, so it's 360 and also 60 degrees, so basically a lot more rotation, go a complete circle more. Just like the hands of the clock, you know, at 8 in the morning or 8 in the afternoon, they look like they're in the same position. The terminal edge of the angle that is 60 degrees plus 360 will be in the exact same position. So a 420-degree angle is said to be coterminal with a 60-degree angle. And in fact, you could find an infinite number of coterminal angles to any given angle just by adding 360 or subtracting it repeatedly. So to give you an example of this, let's just say instead of an angle that was 60 and 360 more, I could start by rotating the opposite direction, the negative direction, until I arrive at that same terminal edge. And that would give me an angle which was 60 degrees subtract 360. And we could collect those together and say negative 300 degrees. So a negative 300-degree angle is also coterminal to 60 degrees. It is also coterminal to 420 degrees. All right? So coterminal angles differ by multiples of 360 degrees in the degree angle measuring system, or 2 pi radians if we are talking about the radian system. One other important fact that you need to know, coterminal angles have the same trig values. Okay, they have equal trig ratio values. Let me give you an example. The cosine of 60 degrees we know is 1/2. All right? Because I know that fact, and also this hopefully makes sense, because if I draw a 420-degree angle or a negative 300-degree angle, the triangle that I would make for my reference angle would be a 60-degree reference angle in quadrant 1. So there's a lot of reasons for this, but basically it's important to have that understanding that cosine 420 is also 1/2, and cosine of negative 300 is also 1/2. Because they have that same terminal edge. So often what will happen is if I ask you for the cosine of say 420, the way I would have to think through that, if I was trying to find the actual value from the values that I have memorized, I would take 420 and subtract 360 until I got something that was recognizable or between 0 and 360. So I would first go 420 minus 360 is 60, and I'm certainly not saying that 60 and 420 are the same angle value, but when I find the coterminal angle, I can then get my cosine, which is 1/2, and essentially then know the value for cosine of 420. So we use coterminal angles to take large angle values and get something a little bit more recognizable, or between 0 and 360 to reference, right? So down below, a couple questions. Now you can just take a look at these and pause the video and see if you could do these. But find an angle between 0 and 360 that is coterminal to 900 degrees, right? So imagine, what would you do? Okay, and you can certainly use your calculator for these. You could do this by hand, just for the sake of time. What I'll do is start with a 900-degree angle. Okay, if I want something that's coterminal, I will subtract 360. Okay, and I get 540 degrees. That's coterminal to 900 degrees, but it's not quite the right size yet. So I'll subtract 360 again. 180. So 180 is an angle between 0 and 360 that is coterminal to 900 degrees. And that's all I'm looking for. You could show your work. You could do this in your calculator. Next up, find an angle between 0 and 360 coterminal to negative 60. Okay, so just start with negative 60 and add 360. And this is one that we have looked at a number of times before. That's a 300-degree angle. So that's a keeper because it's between 0 and 360. All right? Last, and I just want to include this because this can sometimes be an issue because of the fractions. Find an angle between 0 and 2 pi coterminal to 17 pi over 3. Okay. Same exact question that we just looked at, but now this is dealing with radians. So the first thing I'm going to do is take 17 pi over 3. And rather than focus on 17 pi over 3, I'm just going to focus on the 17 thirds part of the number, so the coefficient of pi, 17 thirds. Okay. In my calculator, I'm going to start with 17 thirds, okay, which as a decimal is about 5.6, and I want to subtract away 2 pi until it is small enough to be between 0 and 2 pi. So what I do on my calculator is I actually just subtract the number 2, and I'll put the pi on again at the end. So 17 thirds minus 2, and I'm looking for something that's going to be between 0 and 2 pi, and if it's still too large, I'll subtract 2 pi again, or just the number 2. Subtract 2, and then we have 1.66. That is definitely a number between 0 and 2 pi, so I'll hit the math button and convert this into a fraction. Hit enter to select the fraction converter. Every calculator will do this, it's just a matter of how. So 5 thirds. Okay, so if I was showing my work, I might show that I subtracted 2 a couple times, or subtracted 2 pi a couple times. I ended up getting 5 thirds, and then we just put the pi back on at the end. 5 pi over 3. All right, so 5 pi over 3 is an angle that is between 0 and 2 pi. It is coterminal to 17 pi over 3. Okay, so that was our goal, to look at what are coterminal angles, how do you find them, and then a little detail about the trig ratios and how coterminal angles have the same value on their trig ratios. All right, thanks.